Hello everyone, my name is Ankur. Today we are going to talk about how we can handle execution of KRM function and how we can leverage them. In our previous video we have talked in detail about KRM functions. So just for the recap, KRM functions are small language independent executable programs that are packaged as container and perform CRUD operation on KRM resources. They basically transform the KRM resources in a predefined and holistic manner. So now that we know what KRM functions are, how valuable they can be, and what are the values they bring to the Red Hat. But there is still one question that need to be addressed, that is, how do we leverage these functions? To leverage the benefit of KRM functions, we need some way to handle the execution of functions in Crane or other projects. So I have come up with a couple of approaches to address this particular issue. So the first approach is to have a subcommand in the Crane CLI that can run KRM functions. This is the general synopsis of the command that we will follow. To run a function, we'll use this Crane run function command. As I said, this command will be used to transform Kubernetes resources using the function which we will provide. And image is the container image of the function that we want to execute. The command also supports some optional flags and tag arguments which can be passed to the KRM function. This syntax is in sync with the Crane command line utility, where you can see the export directory is the directory containing resources, and this is default to the export folder. Similarly, transform directory specifies where the output will be written, and if not specified by default, it will take transform or it will create a transform directory for that. Environment env are the list of local environment variables that need to be exported to the container function that we are executing. And we can pass arguments to the function as a key value pair. So here is how the function execution looks like. So our input item will be given by our export directory, and function config, here we are providing the image, function image, and the argument that goes with it. So that will be function config, and output item will be the resources that are transformed and written to the transform directory. Another approach is a library to help execute KRM functions. Not every project has a command line utility, so we cannot add a command to handle function execution. And even if we are doing that, it will be a replication, and that defy our purpose of code reusability. So with the help of this library, we can integrate function execution capability with any project, and we can execute multiple KRM functions together with this library. It also supports function as an executable binary along with the containerized images. So in a bigger picture, this is how the library utilization will look like. For the library, there are two input that we want to provide. First, being the input resource that we want to transform, and along with that, we also want to pass the function object, which is defined by this custom function struct. Once those two things are passed to the library, it will run that function against the resources and provide the result back as a resource list. So this resource list is also a custom object which consists of runtime objects. So these runtime objects is nothing but the resources, that the transformed resources, I would say. And result is the result of each function. So this result is basically metadata to debug or for observability. So this is the Crane sub command where a run function we have created. So in this run function, this is the synopsis as I have already talked about this, and these are the flags which we are providing to support this particular command. Now I would like to show you an example on which we will perform this particular function command. So this is a Kubernetes resource. Here you can see the labels. There are 3 labels for this, and now we'll see the function image which we have. So we have this set label image which will set a particular label to the given input resource. So here we are providing test data explicitly because its name is not export by default, and these are the arguments which we'll provide to the function. So these will be the labels. So here you can see that transform resources are returned to the transform directory as we have not provided it explicitly. Now we will see how the transform resource look like. So here you can see the app name is changed from Redis to MySQL, and env equal to dev is the new label. Going to the next. So first we imported the library, KRM function library, which we have created. And again, I just want to show you an example. So this is our resource. This is the same resource which we have used in the previous example. Here you can see that there is a name and labels in the metadata. And this is the function object which we will pass to the library. So there are 2 things that we passed, one being resource and second is function object. And this is the function object, how it looks like. In the config web, we pass the arguments to the function. So one function is an image, second is an executable. So this is for the example that we support both an executable binary and function image. Here we provide all this data to the library and then we execute. The result of execution is a resource list which consists of runtime object, slice of runtime object, and result which is the result of each function. Now we'll run this and see how the transform resources looks like. So here you see that we have an additional label that is env dev, which we have provided as part of our config map in the set labels. And in set namespace, we have set the namespace to libdemo, which you can see on your screen. These are the references to the work I have been doing this summer. I'll provide link to each of these in the description below. Thank you.